Hi guys, I'm here. I'm going to try to make this as brief as possible, but there was a lot of questions. So I'm going to quick go through. I just want to talk you through a couple situations you might see as you're studying tonight. Be prepared to kind of have this thought process as you're approaching problems. First thing you want to ask when you're looking at a problem, is there a sequence of events? If there is a sequence of events, think about the multiplication rule. You take the probability of the first event times the probability of the second event, and so on and so forth. The main thing you need to think about is that a problem where they say something about without replacement, because then the probability of the second one will change based off the first one. For example, I think the disc problem in the Schoology exam was like that, where you were pulling out red disc and then a blue disc, or a red disc and then another red disc. If the multiplication rule isn't working for you, you want to try the tree diagram. Next, another situation might be you might have only one event that's taking place. In that case, it could be a simple probability, or it could be where they say the word or. You'll need your addition rule there. If there's only two events and they're wondering about the probability of two events, sometimes or one event based on these two events happening, you may want to draw a little two-way table, and I'm going to give you an example of that in the problems coming up. Please, please, please make sure you know both ways to prove independence. They are both very important. You only need to use one way to show me when I ask, are they independent? You cannot just give me an explanation. You need to use some sort of math using strategy 1 or strategy 2. If you see the word both, that means you need to use a Venn diagram. Where do you start? The middle. Finally, I have a little challenge for you. If you know A and B are independent, could you fill out the Venn diagram for here? The probability of A is 0.3. The probability of B is 0.2. If I would fill out a Venn diagram, give me a second here. I know that all of A has to be one circle. So we'll say it's right here. All of A, this whole circle needs to be 0.3. And all of B is going to be right here. This whole circle has to be 0.2. There's a problem though. I didn't give you the middle. But what do we know? I told you they're independent, right? So what does that mean? You could multiply the probability of A and B together, 0.3 times 0.2, to get 0.06 for the center. And now you can find the probability of just A happening by taking 0.3 and subtracting 0.06 from it. And the same goes for the other side. Moving on, this one was in the conditional probability worksheet, but someone wanted me to include this in the video. A die is thrown twice. Determine the probability that the sum of the rolls is less than 4, given that at least one of the rolls is a 1. Or the first roll is a 1. So what I did first actually, whenever two events are happening, a die is thrown twice, I'm going to make a little table. This is all of the sample space. If I keep filling it out, I'd have 2, 2 here, 2, 3, 2, 4, 2, 5, so on and so forth. Okay, let's go to part A. The probability that at least one of the rolls is a 1. That's the given, because it says, what's the probability? The roll is less than 4. Right here, given at least one of the rolls is a 1. At least one of the rolls is a 1 is right here. This is one option to get at least one of the rolls being 1, and also right here. At least one of the rolls is 1. When you're doing a conditional probability, in the denominator, I'm going to put all the options for whatever is to the right of that line. Okay, so here we go. At least one of the rolls is 1. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 options. Now, out of these options, because the probability now is out of my given, how many are less than, not equal to 4, excuse me, less than 4? There's 1, 2, 3 options where the sum is less than 4. And that's where we get 3 out of 11. Part B says, what's the probability that given the roll is given the first roll is a 1? Okay, that changes things for us. So now what I'm going to do is I'm going to put a rectangle over this row. This is the row where the first roll is a 1. So that's my given right here. I'm only dealing with these outcomes here. How many outcomes do we have? We have 6. Now, out of these outcomes, how many have a sum that is less than 4? There's one here, and there's one here. That's 2 options. So my probability is 2 out of 6, or 1/3, or you can write that as a percentage as well. Studying different options for you guys to study. Look at Schoology, retry those quizzes, review with your review assignment. Look at your book assignments that are posted online, and also look at the YouTube channel I've posted. Another rolling dice question. Okay, I'm going really fast because there's so many to go through, so make sure you pause and write down any questions in your notes that might come up and try to find me tomorrow morning so I can answer those before the test. Number 75, 5.3b, rolling dice, another dice one. You roll 2 fair dice, fair 6-sided die, 1 red and 1 green. Right away I'm going to read that. I'm going to say, okay, well, what's my sample space? What's going on? And I'm going to fill that out. So I have my red dice outcome and my green dice outcome. Now it says, are the events sum is 7 and green die is 4 independent? Justify your answer. Remember, I like strategy 1 for proving independence. Okay, I'll write down the strategy 1 again. It's the probability of B given A has to equal the probability of B. Does it matter what comes first? No, you can pick. It doesn't matter. I just read left to right. So are the events the sum is 7? That's a little summation sign. Sum 7. Given the green die is a 4. Has to equal the probability that the sum is 7. Remember, these are 2 separate problems. So I'm going to do the left side first. Given that it's a green 4, what am I going to do? I'm going to highlight where it's a green 4. So green 4 is right in this column. I'm always going to circle or highlight the given. That's the key. There's 1, 2, 3, 4, 5, 6 places I could have a green 4. Now, out of those 6 places, I want to know what's the probability that the sum will be 7. Well, the sum is 7 is only in one spot, and that's right here. So I messed it up. 1 second. I'm going to pause it. I flip-flopped it. Okay, I had to erase something on the smartboard. Sorry. Okay, so like I said, what are we dealing with here? We're dealing with all the green 4s. That's that yellow highlighted row. Out of that yellow highlighted row, there's 6 outcomes. From those 6 outcomes, there's only 1 outcome where the sum is 7. Now on the right-hand side, this is always out of all the grand total of outcomes. So there's 36 total outcomes. How many are of those 36 outcomes do we have a sum that's 7? If I highlight it, you can see it's right here, 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 and here. So that's 1, 2, 3, 4, 5, and 6. 6 out of 36. Those are 2 equivalent fractions. So yes, the 2 events are independent. Independence has come up quite a bit. Make sure you understand it. I have some videos posted as well if you don't. An athlete suspected of using steroids is given 2 tests that operate independently of each other. Test A has a probability of 0.9 of being positive if steroids have been used. Test B has a probability of being positive if steroids have been used. Has a probability of 0.8 of being positive if steroids have been used. What is the probability that neither test is positive if steroids have been used? Okay. Again, I think the biggest thing is just write down the information they've given you without all these words. So what do I know what's going on? I have a test A and I have a test B. All the scenarios they are giving me have dealt with someone being positive, okay? Have been positive with different tests, and it's given that steroids have been used. So the first one here, 0.9. 0.9, test A has a probability of being positive if steroids have been used, 0.9, okay, so that's 90% of the time. The probability that if steroids are used and B being positive is 0.8, so 80% of the time. Now I'm going to make some inferences before I even answer the question. Well, what does this mean? That means if steroids are used, A will be negative 0.1%, or excuse me, 10% of the time, which is 0.1. The proportion of the time that steroids are used and B test negative is 0.2. Why? These need to add up to 1 for test B. This needs to add up for 1 for test A. Now, that's as much as I can do at this moment. What is the probability that neither test is positive if steroids have been used? What does that mean for you? Well, that's a sequence of events. Neither test. That means this one is not positive and this one is not positive. A sequence of events. What do I do with these two numbers? I multiply them. And that's how you do number 104. Okay, a question came up about the roulette wheel. I'm not going to explain how to do the table because I did that in class. But I'm just going to quickly go through the probabilities here. The probability of B, so that means the probability that you spin the wheel and you get a black little slot here. There's 18 total out of 38 total slots, and that's the probability. The probability of getting an even number, that's this row right here. There's 20 total even numbers, 38 slots, so 28 out of 38. Describe the events B and E in words. That means you're going to have a spin and you're going to get a slot that is black with an even number. The probability of a black and an even number when you spin, well, there's 10 black and even numbers out of a total of 38, 10 out of 38. Explain why you cannot just add the probability of a black and the probability of an even card to figure out one or the other. Well, I'm going to use 18 out of 38. That's the probability of a black slot, okay? I'm then going to add that up with the evens, 20 out of 38. But what happened? I double counted this one right here. So I have to subtract the both. That's the addition rule. Whenever you see the word or the probability of a black or an even, you can add up the probability of the black plus the probability of the even and then subtract where it happens both times. Okay? So, or I'm sorry, subtract where it happens both at the same time, a black and even. Why? Because we double counted it when we took the row for the even and then again when we took the row for the row or the column for the black. Okay, education among young adults. Choose a young adult, age 25 at random. The probability is 0.13 that a person chosen did not complete high school. 0.29 that a person has a high school diploma but no further education. And 0.30 that a person has at least a bachelor's degree. What must the probability be that a randomly chosen person has some education beyond high school but does not have a bachelor's degree? So that means, well, first of all, before I even answer this question, I'm going to say, well, what's going on here? They talked about someone who doesn't have high school. They talked about someone who has a high school degree and a bachelor's degree. But there are people who go on beyond high school but just don't get a bachelor's degree. Okay? So no bachelor's, but they went beyond high school. I wrote that out in blue. Now I'm going to say, okay, well, what's going on now? They gave me this information. 0.13 for no high school, 0.29 for high school, 0.3 for bachelor. And now they're just wondering, well, what's left? So I added these three up, subtracted from 1 because up top here is all my options. And that gave me 0.28. Let me know if you have questions. What is the probability that a randomly selected person or a randomly chosen young adult has at least a high school education? Where do we at least have a high school education? That's right here, and right here. What did I do? I added it all up. Or I could say, hey, I can use the complement rule. I could take 1 minus the opposite of those 3, which is no high school, and that gives me 0.87 as well. Okay, so airport security, I'm going to make a video about that on Friday because that is going to be a free response type question. Recycling, the same. And that's actually another video in the playlist already on my YouTube channel if you want to look for it. Otherwise, I'll post it on Friday or Monday. And then number 29 as well. I'm going to do that on Monday just because it's a free response, and I'm a little crunched for time right now with all the questions. I love the questions. Keep them coming. I'm going to quick pause it. I'm going to look for one thing, so stay tuned for just a second here. I'm going to quick talk through a couple problems some girls have stayed after they've brought up. I'm not going to do the problems. I'm just going to address a couple things to watch out for. So give me 1 second. I'm going to pause it. You won't even notice it. It will start back up in a second here. Okay, on number 6, it talks about Alex, Brandon, Charlie, and they talk about their probability that they all win their matches. The question, though, says, if they're independent of each other, what's the probability that none of them win their match? Okay, what I want you to think about here, that's a sequence of events. The first guy is Alex. Alex is probability of winning is 0.4, which means the probability of him losing is 0.6. Brian, I think I said Bryn, excuse me if I did. It says the winning is 0.3. That means the losing is 0.7. And then for Charlie, the winning is 0.2. So losing is 0.8. It's wondering the probability that none of them win their first match. That means they all lose their first match. So you're going to find the probability of each one of them losing, and you're going to multiply them together. Why? Because it's a sequence of events. Alex loses, and then Brian loses, and then also Charlie loses. Number 7, this is a tree diagram. Right away you think there's a lot going on here. What am I going to start with? I'm going to start with all boys, or males, excuse me. They have a condition. They have to get tested. Make your tree diagram, check my key. On number 8, you see the word or, okay? Make a Venn diagram. On number 9, you toss a coin 5 times. That's a sequence of events. But then you see of getting at least one tail. That's 1 minus the probability of no tails. Well, what is the probability of a tail? 50%. So what's the probability of no tails? 50%. See if you can figure it out. If not, look at the key or ask me. The last thing I want to talk about specifically is number 12 here, okay? It talks about a box containing 6 red tags, numbered 1 through 6, and 4 white tags, numbered 1 through 4. So what I would do, let me see if I have I'm going to take a picture of this. There are 2 things going on here, right? And so just like I said with those dice, anytime you have 2 things going on, I am going to, in red, put 1, 2, 3, 4, 5, and 6. No, and not in white because that's hard to see, so I'll use a different color. Maybe I'll use light pink. Here I'm going to put 1, 2, oh, that's not really working. Okay, it's fine. And now it's easier to do my sample space this way. I know I have all my white tags here, and then I have my red tags here. If it would help, maybe bring a colored pencil tomorrow. But this first one then would be a white tag of 1, and then a red tag of 1. The next one in the sample space would be a white tag of 1 and a red tag of 2. And you just keep going down, fill out that sample space to help you answer those questions. Okay, guys, good luck studying. I hope all goes well. I don't know where my little stopper went. There it is. I'll post this tonight, and hopefully you guys have a great night studying. Take care.